So actually, that's cool. I'm after you because I did kind of exactly the same, like some grid, some ants on a grid. Uh, so yeah, and I kind of faced the same frustrating issues. But yeah, so just a quick reminder. But yeah, it's an agent-based algorithm, and each ant is an agent with some rules to interact with its environment. So at first, my initial idea of ants was just I have some ants at my home. I want to do a 3D model of my kitchen and try to predict the route of the ants, but it was like I thought I would spend much more time to the 3D part. So I wanted to do something simpler, so just to the environment, but with several colonies of ants. And I wanted to also add other species or elements that ant could interact with. And then I wanted to like train the colonies to maybe compete with each other for food using the other species to maybe, I don't know, I had the idea to put beetles, and maybe the ants could use beetles to step on the other ants. But yeah, it was kind of a project with like they could learn a strategy in real time, maybe investigate some optimization. But yeah, it was a bit too much for a 20-hour project. Yeah, even with ChatGPT. So just what I did was to simulate a world, a 2D world, but also on a grid. And so in my implementation, there are several layers of grid, and each pheromone, for example, is on one grid, on one different layers, and like that, it's possible to have several colonies with several kind of pheromones and yeah, other, for example, walls or anything. But yeah, I didn't use that much, and some evaporation and diffusion of pheromones, even if the diffusion is like very poorly implemented, so it's very slow. So actually, it's on the side for now, but yeah. And so in the model, ants are still able to find food and bring it to their home, but yeah, and it's already possible to explore a lot of that with the environment. So let me just show you a simulation. So I couldn't really take videos, but so it's like the so here it's the colony, and then ants start. So I'm using a grid, so it's they move like that, and so the green stuff are the food patches, and so ants starts to find the food, and at some point, I don't know if you see it.
Yeah, no, it's perfect.
Yeah. So the blue traces, sign traces, are the pheromone like to food, and the red one, no, is like the to home pheromone, and the red are the to food pheromones. So yeah, they kind of explore their environment. You see some like patterns emerging, but still there are some ants kind of in the totally wrong direction, and there are also some problems. For example, ants might follow each other. For example, here one ant just follows another one. Yeah.
So there is no diffusion here, or there is?
No,
Okay.
there's no diffusion in the tree.
What is the white one?
It's usually when it's so if there is the white dots are actually the ants, but if there is a white trace, it just they are overlaid, like it's cyan and red, so it just makes white. For example, yeah, usually it's when two ants are following each other. Yeah, so that's kind of it. So in my implementation, so ants have several parameters, like they have their position, they have the two states, either they're going to their home or looking for food, and they have some direction, some food capacity, and I added some sensory noise, like how they detect food is a bit noisy, and I cheated. I had the same idea of gradient, but actually I didn't do that. I kind of made a sense of orientation, like they always had the idea of the direction of their home, like at any time. And yeah, it's they're initialized with some random direction in the colony, and they drop one pheromone at each step. And so I use it's a bit cut, but yes. So yeah, so each ant have actually a direction, and so they actually consider only the adjacent direction. For example, if the ant has actually current direction of like 1, 0, it actually consider only the 3 adjacent direction, I mean the current one and the 2 others, especially to avoid them like going in circles or going back, or doing some crazy stuff. And then they check the pheromones, and if some pheromones are present, they choose the new direction between those 3 according to the density of pheromones, using that as a probability. And if there is no pheromones, they tend to go forward with some probability, or to turn in one of these 2 adjacent direction with the remaining probability. So actually, that was the first implementation. But so there were a lot of problems emerging, like ants following each other and everything. And so I kind of cheated by adding that kind of noise, which was proportional to the amount of pheromones they would detect. For example, there is very little pheromone, then adding some small noise would totally erase their sensation. So it's kind of proportional to the sum of the concentration of the pheromones in their 3 vision space or vision cell. I added their orientation, so when the ants are going toward their home, they pick some. They still follow the pheromones, but with some probability, they just go toward the home direction. No matter the pheromones they sense. So it's kind of cheating, but and there is also some forward bias. So to avoid them turning too much or doing crazy loops, they even something I added kind of at the end, but they will prefer. I just multiply the pheromones density with a little arrays of probability to just encourage them to go straight. And yeah, but so there are still problems, like still ants are following one another, and it's not very efficient. And yeah, there are still many more steps to do all that reinforcement stuff and everything. Yeah. So yeah, I think that's kind of my project.
Questions? I have a few questions. So can the ants, so what was not clear to me is the ant can have only the 4 cardinal directions, or can it also go in diagonal?
Yeah, it can go in diagonal. That's why.
Okay. So when it goes in 1, 1, it can observe 0, 1 and 1, 0. Let's say.
Exactly.
Okay, I see. So you mentioned this home direction trick. So I understand this how it works. So it biases, like if an ant is following a go home pheromone, it's biased to follow it in the right direction in some sense. Because at some point you will just turn it in the right direction and then it will just continue along the highway.
It's just at each step, there is a certain probability that the ants go toward the home direction regardless of the pheromones level.
And this flip can be like only in the 3 possible directions, or it can just turn around completely?
I think it could be a complete flip.
Okay, yeah.
But I'm not sure because I didn't see that in the simulation. So
okay.
But I think it might do a complete turn.
Okay. And the other question was, so because of the problem that Tobias mentioned about understanding, okay, I have some pheromones, but where is the way which leads me towards the source? So in your case, you don't have that, right? So for example, for the food, if I just have a food pheromone highway and I stumble upon it, I have no idea in which direction I should turn, right? Is this correct or?
Yeah,
Okay.
it's
Okay.
even a bit. That's also one reason for the noise, because if an ant arrive on a, for example, if there is the food and the pheromones to food like that, and an ant will
Yes.
arrive like that, if it just choose based on the highest concentration, no, in that direction it's working.
But it's not clear, right? Because
For me, it was always choosing the wrong direction because it's trying to follow the ant because it's higher at the position where the ant currently is than where the ant was.
yeah, of course.
Yeah.
Yeah.
And so if it's just going towards the highest pheromone level, then it will always go in the wrong direction.
Yeah,
Right. So this is for the first time that finds
For
the
the
food,
first
right?
time, but afterwards,
But let's assume that you started with a huge highway of ants, right? So
then
it's approximately constant everywhere, right? The pheromone.
Yeah.
And so there is no way to know where the food is, right? Which direction of the two the food is for the ant?
No.
Okay. Okay. No, I was just wondering about that because this is a problem I hadn't think of. But if you let the simulation run long enough, do you actually get like 3 main highways and that's it? Or
Yeah, but they are. I mean, ants. Maybe with diffusion would solve
yeah, I
that
think
a
diffusion
little.
would help a lot.
But right now, so there are ants who are in that region, kind of go on the highway, but ants that are a bit far apart, just like stay like in random direction. But yeah, also putting that kind of vision, or without the orientation, like at the beginning when ants were finding some food, they were just like going with their food in some random spaces, not at all during
that's the problem.
their home. So,
Another question I had is, what is the number of ants that you put in your simulations?
I think the one I showed was around 400.
400. Can you go to more ants, or it starts kind of slowing down?
No, I think it's quite robust.
Okay.
I didn't check like thousands,
Okay.
but at least for a few hundred.
I'd be curious if you launch a simulation with like 500 or 600 now, and then we check on it after the next presentation.
Yeah.
Is the food limited in supply or it's unlimited?
It's limited.
Okay.
When the
Okay.
But it's like actually the food capacity of the ants. Like if they take a small portion of food, then food can last for a very long time. It's a bit implemented on the ant point of view, like how much they take from food.
Okay.
If they don't take anything, they will act the same, but the food won't decay.
And did you observe the behavior of what happens when kind of the food is depleted? Like how do the ants break out of the...
They take quite a long time to do something else. For a long time, the road is staying.
Okay.
Not in the video of that guy, like
yes.
In the course, it's also stable, but they diffuse more quickly.
Okay.
So it's a bit more fixed. But still, at some point, they go back to their occupation.
And if an ant is looking for food, it completely ignores the 2 home pheromones. Is that correct? Or?
Yeah.
Okay. I think that's it for me. It's